Jai Hind viewers, welcome to AKGC Digital School. My name is Pankaj Singh, Faculty of IT Department. Today I am going to deliver my video lecture on a subject Computer Organization and Architecture, and my topic is cache memory. So before going to in detail about cache memory, let's have a brief introduction about the memory hierarchy and their positions in a memory pyramid. First is register, second is cache memory, main memory and secondary memory. If we talk about the speed, which one is faster? The fastest, that is register for storing or access the data, and second one is cache memory, third one is main memory, and fourth one is secondary memory. And in term of storage, secondary memory have the max storage, right? So today we will go for cache memory. So what is cache memory? Generally, cache memory is a memory of main memory. What it mean here? That is a special part of main memory. It is constructed using SRAM. Generally, main memory divided into two parts, RAM and ROM, and RAM memory is designed by the help of SRAM and DRAM, right? So to make access of memory content from cache memory, we keep some part of a main memory apart from the main memory that will be nearer to the processor, or we can say CPU, so that CPU can easily access the content from the cache memory. So if we talk about the terminologies that are used between CPU, cache memory and main memory, the information or data share between cache memory and main memory, the terminologies is used as in term of block transfer. And if we talk about the sharing of content between CPU and cache memory, that is in a term of word transfer. So we can say that CPU on its memory, that is register, and memory on its fastest memory, that is cache memory, or we can say that lie in between CPU and memory unit, that work as an interface between CPU and main memory. So what is the advantage to keep cache memory in between? When a CPU searching for any page or any address, it first go to the cache memory. If the required address or page number is available in a cache memory, that's known as hit ratio. If the concerned address or the page is not available in a cache memory and machine processor will go to the main memory, that's known as miss ratio, right? So generally we required a mapping techniques for mapping the blocks from main memory to the cache memory. For that we will go in a detail in a next slide. So that is a brief overview about where cache memory is lie in a memory pyramid. Cache memory is a part of which memory, as I said earlier, that is a part of main memory, or we can say that is the memory, fastest memory of main memory. Why we make it in between interface? Because the speed of CPU and main memory is mismatch in term of speed, because CPU process at a very high speed and memory take more time as compared to the CPU access time. So to make it compatible, memory is used interface in between CPU and main memory, that is cache memory. So, I read here what are the basic terminologies and what is basic purpose of cache memory. Cache memory is a small amount of fastest memory reside between main memory and CPU, may be located on CPU chip or module. The fundamental idea of cache organization is that keep the most frequently accessed instruction and data in the fast cache memory. The average memory access time will approach the access time of the cache memory. Cache memory is based on the property of computer program known as locality of reference. So, the data that is frequently and that is required repeatedly by the machine, or we can say processor, that is keep in a cache memory location, so that CPU can easily identify the required pages that are frequently used or that is needed for any operations that must be available in a cache memory, but that is not practical possible to keep all the pages or all the block in a cache memory. For that we will use a page replacement algorithm in which the block of cache memory will replace with the block of main memory that is required. So, as I said earlier, and that is also mentioned in a given slide, locality of reference. So, what is locality of reference? Locality of reference means the frequently data required for access for any operation and repeatedly required for any operation. These instructions may be once in a loop, nested loop, or few procedure called each other repeatedly. This is called locality of reference, right? So, the data I said earlier that is frequently required and operate for many applications, and that is required in n number of processing that will be accessed by the processor from the cache memory and processed for required operations. It works in two dimensions. First one, temporal and spatial locality. What is temporal? If an item is referred, it will be tend to be referred again soon. There may be a possibility if any block or page is required by a processor, there may be a possibility, higher possibility we can say, to refer the page again. Example, loops repeatedly called subroutines, setting a variable and then reuse it many times. And second is spatial locality of reference. If an item is referred, item whose address are nearby will tend to be referred soon. So, there is a possibility if for example, in a block we have 10 address and we access address number 5. So, there is a more probability that the address number 6 and 7 is required for the further operations. So, on this mechanism cache memory is worked. I also said earlier, the performance of cache memory is frequently measured in terms of quality called hit ratio. What is hit ratio and miss ratio? Hit ratio is simply, in simple term, if in a layman language I explain it, if a CPU searching for any page or block or that is available in a cache memory area, or we can say in a cache memory part, that's known as hit ratio. And if for any address or block, processor will go to the main memory and that is not available in a cache memory at that time, such term is known as miss ratio. Now, the topic that we will discuss in a detail. For mapping the cache memory from main memory to cache memory, we are using here 3 different techniques. These techniques are direct mapping, associative mapping and set associative mapping. So, why we required to map the cache memory? What are the purpose and what are the advantages? For that we have to go through these 3 methods in detail. So, now I will take the first method, that is direct mapping. For example, if the size of main memory is of 20 address, for example, and the size of cache memory is of 4 address. if we talk about in a size of MB or KB, it is of 1K and that is of 256. Okay, means it consists 1024 and it consists 256 address. So the capability of cache memory is only to hold only 256 address from the main memory. So we have to choose which address is required by the processor on a behalf of locality of reference, and the processor location is here, CPU. CPU first go to the cache memory, and if address is not find out in that location, then it will go into the main memory. That is hit ratio and that is miss ratio. So in direct mapping, address is divided into 3 parts. What are these 3 parts? Tag, block and word. Okay. So total address length equal to, in term of bit, log 2 size of main memory. Like for example, if we have a memory of log 2 of 1K, that will be log 2 1024, that will be 2 to the power 10, log 2, that will be 10 bit. Okay. Likewise, to calculate the size of block in term of bit, that is cache memory block log 2 of 256, that will be log 2 2 to the power 8 equal to 8 bit. And the word size generally given in a question, the word size of cache memory and main memory will remain same. And to calculate the tag, we use main memory block divide by cache memory block. Okay. These are basic formula that is required to calculate the numerical value in a numerical, that is required to understand the actual concept of mapping the address from a main memory to the cache memory in a direct mapping. One most important point in direct mapping, that is the location of address that will be mapped to the cache memory is fixed, means that is static. For example, if we talk about the 20 address 0, 1, 2, 3, 4, that is 19. The mapping of main memory address to the cache memory is fixed. Like 0 address will go to the 0 location, 1 will go to the 1, 2 will go to the 2 and 3 will go to the 3. After that 4 will go to the 0 location, 5 will go to the 1 location. So after that there is a sequence of address like at address cache memory address 0 consists 0, 4, 8, 12, 16 and so on. Likewise, address 1 consists 1, 5, 9, 13, 17, so on. Like address 2 is mapped with 2, 6, 10, 14 and 18. Likewise, address 3, 3, 7 and so on. So this mapping is fixed. If a system or CPUs call address 4, 9 and after that 8. So 0 is occupied by the 8, 1 is occupied 9, and if it call 12, so 12 will queue at only location 0, although we have other 2 locations that is vacant, but that will be not occupied because that is fixed, because 12 will go only to the address location 0. But if we compare all these three methods, direct mapping is fast as compared to the other two methods because it is simple and fast because all location is pre-mapped and that is a static method. And what is basic difference between direct and associative mapping? In associative mapping, cache memory location and main memory location are dynamic. Means any address from the main memory can be mapped anywhere in a cache memory. So, in this field, the address length is divided only into two parts, that is word and tag, right? That is the basic difference between direct and associative method. For example, if the address length is 10, it is divided into three parts in direct mapping, like 4, 4, 2. These are tag bit, block bit and word bit. But in associative mapping, it is divided only into two parts, word and tag. That is the basic difference between associative and direct mapping. If we compare both methods, which one is better? That is, direct mapping is better, fast, but if we talk about in a dynamic mode, the second one is better. And the third is set associative. Set associative is nothing, that is a hybrid mode of direct plus associative. In this, address is divided into three parts, tag, set and word. What is set? Generally, for example, if we take the same example for set associative, in a cache memory, if we have 4 address, that will be divided into two parts, 2 for direct and 2 for 3 and 4 will be used for associative. Means by default that is a two-way set associative. The cache memory is divided into two parts. One part is static, that will be used for mapping the address from main memory to the cache memory, and half address will be used for dynamic purpose. Means any address from the cache memory will locate to any address of a cache memory. So, that is a basic difference between these three methods. Generally, it is known by the above two methods, associative and direct method, and that is a hybrid mode, or we can say a combined approach of above two methods. So, hopefully that will be clear to all of you about what is cache memory, locality of reference and their different mapping techniques. In the next lecture, we will go through for their different page replacement algorithm that is required, which page number or which block will be transferred again to the main memory and which new block will be copied to the cache memory. Thank you.